Another thing to keep in mind, a lot of these harmful chemicals can be endocrine disruptors. Endocrine disruptors, because they're impacting hormones, those can be at relatively low concentrations and start to cause various problems. So it doesn't necessarily take a whole lot. Hey, it didn't kill me, I'm fine. No. You may have a lot of things not working the way they should and not be killed. So you have those types of challenges as well. You have long-term effects, sometimes complex relations to different factors. DDT, one big impact there was that birds up the food chain, especially fish eating and other predatory birds, up the top of the food chain, so they're accumulating a lot of these chemicals. And then it turns out having too much DDT in them tended to cause the birds to lay eggs with thin shells. And this is not good news when mom sits on the eggs to keep them warm. You break the eggs. So, no eggs, no baby birds, populations were declining. Another example, mercury is among the things that is a noticeable component as a contaminant in coal. So when we burn coal, say to make electricity, like the smokestack over at Cliffside that you can see from campus, that's putting a noticeable amount of mercury out into the air. And that mercury, in various chemical forms, gets into ecosystems and gets concentrated going up the food chain. And so the larger fish, like what we would tend to eat, often accumulate dangerous levels of mercury. If you take a look at the recommendations for health, you'll see that rivers across the U.S. and lakes have a statement saying that people should not eat more than a certain amount of fish per week from these areas due to the levels of mercury, largely due to burning coal. And depending, mercury is especially bad for growing children, so either young children or pregnant women should especially be careful on that amount. If you read extra carefully, you find that when it says not more than one meal of fish per week or 2 meals of fish per week taken from these sources, actually, meal, that means serving. And by serving, they're talking about the diet idea of a chunk this big, not a plate all filled up with as much as you could pile on the buffet. So these are affecting people as well as the animals. Here's an example of the effects in DDT, pesticide. Now, using it in the U.S. is illegal. We didn't ban making the stuff and selling it to other folks, though. It is not entirely eliminated from other countries, so there's some regulatory stuff that could be improved here. But these bars reflect the amount of DDT in tissue of animals going up the food chain. So we start with the phytoplankton, the producer. Not a whole lot. Shrimp eating the phytoplankton. Okay, that's somewhat more. Eel eats the shrimp. needlefish eating eels, a gull eating larger fish such as the needlefish. It's got lots more DDT as it's building up all the DDT and all the fish it eats through its lifetime. Each of those fish have built up the DDT from all the things they ate, and so on along the system. Living things made up of various molecules, all the way down to different types of atoms. We looked at this quite early in the class. And these also occur out in the non-living environment. So we have many types of cycles of these different substances going through both the food chains and food webs, and also back and forth between the living things and the non-living environment. Now there are all sorts of types of minerals that we need some of. You need a tiny amount of selenium, for example, for good health. Too much, and you're poisoned and are dead. Too little, and you're sick as well. But really big ones here: carbon, nitrogen, phosphorus, and the water cycle. These are really big, major impacts on living things. After all, carbon, nitrogen, phosphorus, the water H2O, carbon, nitrogen, phosphorus, hydrogen, and oxygen are the main types of atoms in our proteins, our fats, our carbohydrates, our nucleic acids. So carbon cycle, this is the cycling of carbon back and forth through abiotic systems and living things. Again, we're carbon-based organisms. The biological molecules are characteristically built around a backbone of carbon. But we also see carbon. Of course, carbon dioxide is as a gas in the air. It can dissolve in water on various ways. We can have basically just carbon dioxide in the water, or it can form ions such as carbonate and bicarbonate. There are also many carbon-containing rocks. Calcium carbonate, very common, limestone, marble, things like that. And then we've got all the carbon in living things and dead stuff, whether it's relatively fresh dead or old, buried away, like coal, oil, gas types of stuff. And so we have carbon going to the air as carbon dioxide, carbon being used up by photosynthesis, by reactions with rocks, dissolving water, things like that. Back and forth, many different things going in various directions. And the whole balance of this determines, are we seeing more carbon dioxide going different places? Is it staying more or less consistent? One thing to note, carbon dioxide, when you dissolve it in water, makes an acid. We saw this back with the respiration lab, blowing into the red tube. If you blew too hard, it made it splash all over the place, but blowing more gently, you saw it turn yellow. And that was due to the change in pH, not to the carbon dioxide itself, but the carbon dioxide was causing the pH change by reacting with water, making acid. So when we get more carbon dioxide in the air, more dissolves in the water, water becomes more acid. And there are associated problems with that. Carbon dioxide and methane, another gas that is produced by living things, going into the air, they are greenhouse gases. They'll tend to make things warmer, so there are other impacts there. Plate tectonics. As things move around, it changes the shape of the land. This affects our carbon cycles as well. Lots of big mountains, that's lots of rock exposed to the air, chemically reacting, using up carbon dioxide. Relatively low-lying land, we haven't had continents crashing into each other much. Then, not so much carbon dioxide being used up. Different things like that. Lots of volcanic eruptions, that might put out more carbon dioxide. Lots of things go on. We burn stuff, that makes carbon dioxide. Wood or fossil fuels, coal, gas, oil, these will tend to make carbon dioxide. Also, changing vegetation. We cut down trees and then instead don't let new trees grow in their place, but things like grass. Then that's using up less carbon dioxide out of the air with photosynthesis. We'll tend to see more carbon dioxide in the air. Change in pH in the ocean. Of course, living in acid, that's not real good. Some things are going to be ultimately reaching their limits. It especially tends to make it more challenging to make skeletons out of calcium carbonate. And that's the most popular thing to make your skeleton now in the ocean. Seashells, corals, certain sponges, crabs, sea urchins, starfish are all using that. Now, different ones have different tolerances, but it's making it harder on all of these. Also, even if it's not so acidic as to actually kill things, living in the stuff, it's going to throw things off. For example, chemical sensing. As the water gets somewhat more acid, the ocean's still on the base side, but it's not as far on the base side as it used to be, then things don't necessarily respond the way they should to the chemicals around them. Their senses of smell and taste aren't working properly. For example, there was one study. Now, a later study didn't seem to detect the same pattern, so that needs more work. But one study reported that fish under somewhat more acidic conditions, although they seemed healthy, they did not pay particular attention to the smell of a predator. And if you don't pay attention to the smell that a predator is coming near you, that's going to be bad for your health. Another example, in crabs, a study found that under more acidic conditions, female crabs were not correctly picking up on the chemicals being produced by their eggs to tell them that, hey, you're carrying eggs around, you need to take care of them. Most female crabs will carry the fertilized eggs around on kind of a flap on the bottom of it, and so they move their legs to wash water over them to have plenty of oxygen, wash away the waste, that type of thing, keep the eggs healthy. But if the mama crab doesn't realize the eggs are there because she's not smelling the chemicals coming from them, then she doesn't do the aeration, and a lot of the eggs are likely not to survive. Again, more carbon dioxide in the atmosphere. It's a greenhouse gas. It tends to slow the loss of heat, make things warmer. In turn, higher temperatures. This will tend to melt ice and snow. Change in temperature affects patterns of weather and ocean currents. Excuse me, both the melting and the warmer temperatures will tend to lead to sea level rise. All of these being environmental changes that are going to put stress on the ecosystems.